Hi everyone, welcome to today Innovation Coffee, TinyML with OpenMV. I'm really excited about this show. Let's bring in our co-host, Robert. Hey Robert.
Hey, that's me. Yeah.
You're muted. There you go.
Cheers. Yeah, thank you. Very excited about this episode as well, OpenMV.
Yeah, and we also have another co-host today. So let's bring in Carl. Hey Carl.
Hey everybody, I'm back. And
The expert is in the house.
Yeah, totally.
Really cool. I mean, I'm really excited to have you guys with me today because we have a lot to talk about. We're going to be talking about something really cool that OpenMV has just done. And I mean, he was telling us earlier how he's been working on this for a while, and it's actually finalized. So I'm really excited to see what it is because I haven't seen it yet. How are you guys doing? Do you guys have any updates or anything that you want to share? Any news, exciting stuff happening in your lives?
Nothing exciting right now.
No,
nothing exciting.
Not really. It's I live in this room. This room is my life.
I mean, on a personal note, I went to the doctor's yesterday, and was that a surreal experience? I don't know if anyone's had to go to the doctors during this time, but I mean, everyone's wearing face masks and face protectors, and it's just, you walk in and you think it's the apocalypse. It's pretty crazy. So
Yeah,
got to experience that.
I went to the dentist a few weeks ago, and I was like, just kind of shocked. The first shock was just seeing another person in person, and I was like, "Oh, you have depth."
Yeah.
It's quite scary. I mean, it's anything that you used to do that was kind of normal is a bit weird now. The doctor is particularly strange because I think people are even more cautious, so that they're all like, big face masks and stuff. But yeah, fortunately, stuff is slow. It's starting again, so that's good, at least in England. But yeah, enough of that small talk. I think we are actually here to talk about something really cool. So let's bring in Kwabena that will talk to us about OpenMV. Kwabena, welcome to the show.
Hey, how's it going, everybody?
Good. How are you?
Doing all right. Yeah, so for this coffee chat, I just want to talk about a new feature that we're launching that we've been kind of preparing for about a year with OpenMV Cam. And basically,
don't give too much away.
Oh, okay.
don't give the whole spiel now.
Okay, gotcha. Mm-hmm.
Yeah, I think we're interested in knowing about you first.
Okay, what do you want to know?
Give us your origin story. Who's Kwabena?
Who's Kwabena? Okay. Well, I guess I grew up in Miami, Florida. Lived out there. Went to school at Carnegie Mellon, and then came out to the Bay Area after that. I kind of do OpenMV in my free time. I started this, I started the project, and well, I'm working on it because I kind of wanted to raise the bar for embedded computer vision. Basically, everyone, I remember Googling online, like someone looking and asking, hey, can you run OpenCV on a microcontroller? And the responses were, very clear no. And there were a lot of different problems related to that, lack of library development, lack of memory resources, and other various things. And so the OpenMV Cam project has always been about how can we make a computer vision library for a microcontroller. And of course, this is a little bit more difficult than just a pure computer vision library, since we have to deal with device drivers, how to boot cameras up, along with I/O pin control. So it encompasses kind of everything, like a complete compute solution. Anyway, and so we've been doing it for about 5 years now, and it's going strong. The company's doing well. It's not like, I can live off it yet, but, I'm happy to continue building it, and people seem to like the product. So we're just going to continue making it better and better. And we hope to kind of become a repository of high-speed open source code snippets for anyone to put in their own projects.
Yeah, it's a really exciting project. I mean, I've been looking at it for the last 2-3 years now, and it's exciting how much stuff you manage to bring out every couple of months or something. Like there's always something new modules, new software. I mean, we'll dig into that a little bit later. I think it's really exciting what you've done. But I wanted to ask you another question. I mean, you said this, you're not living off this. I know what you do as a real job, right? I always laugh because it's like, I don't understand how you have like 2 jobs basically, right? And one is you're running this company that's like amazing, and the other one is your day job. So what's your day job?
Yeah.
So it's quite interesting because it's kind of different, right?
Oh yeah. So for my day job, I'm a electrical engineer lead at Embark Trucks, and so I help build self-driving trucks. It's a very different type of atmosphere though than the hobbyist realm. Prices don't really. I won't say prices don't exist, but you might add 2 zeros to the back on 2 to 3 zeros into the back on every sensor you buy. So when we talk about the OpenMV cam costing $80, and people are like, oh, like $65, and people like might grimace at the price. It's like a real computer vision camera starts at 500 and moves up, and that's for no features. It just outputs images. It doesn't do anything but output images. And so OpenMV has been this nice exploration ground where you can kind of work on building this ideal sensor that has the ability to take pictures but also process that data at the same time, and just kind of seeing what's possible. Versus at the day job, you have to, I love it, but you have to focus on the problems that are immediate right then and there and figure out solutions to that versus try to think about new ways of doing things. And exploring like different hardware builds and etc.
I'm curious about what got you into the world of microcontrollers from the world of like self-driving trucks. And I think before you were doing FPGA stuff as well, right? So how do you kind of go from big to small? Like what made you?
Oh yeah. No, I've actually totally gone the opposite way. So I started out my career as a computer chip designer at Oracle Corporation. I went there because back in the day, that was Sun Microsystems was actually the company that they had bought, and Sun was hiring for design engineers. So when you're doing chip design, there's 2 jobs you can get as a new college grad. You can either be a verification engineer, which pretty much 99.99% of everybody gets, or you can be a designer, where you actually get to write code that does stuff. And so I had an opportunity to be a chip designer, not a verifier, and so I took it. And I got to like work on, really high speed, can't say the numbers publicly, but, very, very high speed chips, PCI Gen 4 moving hundreds of gigabits a second. Anyway, but, doing chip design is a very different field. You work on these really high spec chips that are really awesome in performance numbers, but at the end of the day, they get put into a server room and into a giant box. And if you ever watched Silicon Valley about their the box 3 and etc., that's literally what the chip design world is like. All your effort gets put into a box that's in a data center, which is another box located somewhere far away. And so I wanted to work on things that were more hands-on. And so after that, I got into satellites, working at Planet Labs, doing FPGA engineering for them, and that was really cool. But I wanted to really learn system design, and so working at a self-driving truck company is really the way you can do that. You have the ability to touch everything in an entire computer system, and kind of learn about the cable interconnects, what kind of physical media needs to be used to connect devices, along with learning about how do you need to build an entire system to make something go. It's quite a lot different than just kind of focusing on an FPGA or focusing on a chip, but looking at the entire system and knowing about everything that's needed there.
On the you mentioned at the beginning was design versus verification and testing and stuff. And I mean, I will say I've gone to some of these chip vendor sites. You could think of one here in San Diego, and and it's pretty cool to go into some of these verification labs where they just have racks and racks of switching boards, switching on and off, testing how many cycles they can go on and off for. And I mean, of course, like all of these cooling systems, it is pretty rad to see the verification side too. And then of course they're poking and prodding all the different boards with, different machines. It's pretty cool too.
Oh yeah, but it's not like creative. Well, it's creative in a way. I mean, at least for me though, it's more like they give you a spec, you test to the spec, versus you get to design how to do something. So like when you're doing chip design yourself, you're typically hit with like, okay, I need to figure out how to get like the highest speed. in chip design, the cardinal sin is thou shall not block. And so if you're designing like high-speed compute, trying to figure out how you can push data through different pipelines all at the same time and not result in any time where the chip is doing no work is how you get the best performance. And it's very easy though to mess that up. Like imagine if you code a state machine that takes 2 clock cycles to do something. Well, you just lost 50% of your performance. So in chip design, like performance is a 1/n thing. So if you divide by 2, divide by 3, divide by 4, you get massive performance falls off. Performance falls off at a massively fast rate. So you have to learn how to like write every single state machine to operate in 1 cycle. But the problem is you get into these really tricky situations where sometimes the logic that you're computing, the function, can't be done in 1 clock cycle. So now you have to figure out how do you like unwrap this algorithm and spread this algorithm over a pipeline that can be executed in a pipeline format where you're always doing another execution every clock cycle and keeping the pipeline full. And so at least for me, there was all these like fun problems learning about how to code up, making sure you can maintain that speed and always keep doing something per clock cycle, and then fighting with the reality of, you can't put so much code per clock cycle, so you got to figure out how do you spread the algorithm you want over multiple clock cycles. And then also figuring out how do you maximize resource utilization. In particular for FPGAs, there's a physical chip there that you're using and you're writing code to target. And so learning how to like best optimize your code to target that FPGA and use every single resource available is also something fun that you get good at if you're, I don't know. I just like that kind of stuff. You get like these.
I feel like you could talk. I feel like you could talk for hours about this.
Yeah.
I was actually going to say, it's interesting because actually that's how I started as well, right? Like I started with FPGAs, and then I joined ARM as a design engineer, and I was working on some arbiters for a while. I got a patent, so I can talk about it because it's public. So that was my first patent that I got from that work, of that design work. And then I moved into verification actually, and then I moved to this. So it's like I've kind of gone full circle as well. It's quite cool actually. I mean, verification actually. You mentioned, I think at the beginning I was a bit like, oh, this is not very creative, right? But then you see actually the world of UVM and like in general the world of like building these worlds that are supposed to verify these like little things, right? There's a lot of creativity I find in that kind of infrastructure that you have to build to make sure that these little things are actually working correctly, right? Because sometimes like the verification environment is much bigger than the actual thing, or in terms of like manpower, right?
Oh yeah, it's huge. Like doing chips are massively complicated projects needing many huge teams of engineers. At least for me though, the thing with verification though is like memory access is free. So like, you can just make an array that's a gigabyte large to hold, values versus when you're doing, chip design as a design engineer, you have to actually write code that accesses main memory. And that's a whole, huge machine you have to develop versus it being abstracted into just a little tiny snippet of 1 line of code. So you really get into like how to do things and how to get into like certain performance situations. That's interesting to me at least.
Yeah.
And like clock domain crossing was really interesting to deal with. I don't know, just so many different things that you can get into. I will say though, like while chip design is really interesting and fun, it's very hard to use in the real, in the world, except in very specific situations. Similar for FPGAs, like there's only a few employers who are really hiring for that. And learning how to use microcontrollers is actually a little bit better of a skill, I would think. Having both is great, but like being able to leverage micros, I think, is more useful in that you can actually deploy them because they're cost effective.
I think that's a good segue into the other conversation of so you built this really cool little camera that could do a lot of stuff, and actually you've kind of moved to how can I push the boundaries of what this could do with machine learning. And I think what's interesting is, to me at least, is understanding what brought you to that point. Like, what made you, a question that we asked to a bunch of people at this show before is, what does innovation mean to you? Like, how did you get to that point where you said, actually, I think there is a gap here, and I can, I feel like I can do something in this space.
Oh well, That's an interesting question. I mean, OpenMV didn't start as like a directed path. Like I can't say like this, like what we're doing with OpenMV is, actually like a great, fantastic. I looked at the market and thought this is where cash is and I'm going to go after it like that. It's more like this is a creative thing to me. I get to work on a project that I like doing. I'm happy that people are interested in it and that, I'm getting feedback that people think it's valuable. And it's really just kind of about, I would say it like this. Once you learn how to code FPGAs and such, they're really like exotic and interesting before you learn how to use them. And then once you learn how to use them, you realize that FPGA fun doesn't really start until the $3,000 mark per chip. Like if you're not playing with $3,000 to $30,000 chips, which you can only afford at a company, you're not really going to be doing like super crazy stuff with FPGAs. And so with microcontrollers, you can actually do higher end performance applications than you could do with a cheap FPGA. Like when I look at like lattice parts or other various things, there's a few specific instances where they're pretty useful. In particular with data I/O movement, that's where FPGAs shine. But with compute and in terms of like algorithms, microcontrollers typically outperform FPGAs by huge margins. Like I've looked at like lattice semiconductor parts, and if you look at like an ARM processor running at 600 megahertz or whatnot, its Mac performance will beat and outperform generally any FPGAs. Even if the FPGA has like multiple multipliers, you're not going to hit anywhere near the performance of just a nice hardened silicon.
So Kwabena, I kind of, we're going to hit up on this demo marker here where we're going to start showing the demo. And I don't feel we've talked enough about OpenMV. So like, I want to talk about the camera. I have some questions. I have like some really, really interesting questions. I'm hoping they're interesting. But I was exploring your website and OpenMV, camera, open source, machine vision is what the MV stands for, right?
Yeah, machine vision.
So open machine vision. I noticed that you didn't use the OpenCV library. So like when you're saying, hey, use this OpenMV camera, you built your own machine vision algorithms. Like you built all of this from scratch. So like my main question is like, I mean, when I worked with a lot of people out there, and most times they'll just say, okay, well, if this is an open source project, don't reinvent the wheel, go grab something that exists, fork it, build upon it, do whatever. I want to know your motivation for not consuming OpenCV, why you felt you needed to build your own algorithms, and how do your algorithms fundamentally differentiate from that of OpenCV? Because OpenCV is very well known in the open source space.
Yeah. So my goal wasn't to ever redo that library, to be honest. OpenMV's kind of built its own library just by people asking us to implement things organically and then redoing it. I will say we feature creeped a little bit in areas where we shouldn't be, and I think I'm going to pare down some of the stuff in the library just to kind of focus it towards what I want to be, or I want the product to go. But the reason we did that is because OpenCV fundamentally works of an assumption that memory is free. The best way to say it would be OpenCV assumes all images are floating point 32-bit. So by default, if you have a RGB image, it's going to take 12 bytes per pixel. This is much larger than a compressed RGB 565 image that we kind of operate on when we're in color, which is 2 bytes per pixel. So if you try to port OpenCV directly on a microcontroller, you will find that you can barely support any images, because everything is so large in the amount of space it takes. Additionally, when I kind of joined OpenMV, my co-founder Ibrahim really created the project. We were kind of working with MicroPython and working in a C-only environment, and so we tried to avoid bringing C++ in. OpenCV is a C++ library, so it's not, it kind of goes against that approach. Now, I will say I would kind of honestly it'd be nice to not reinvent the wheel and use OpenCV in most places as possible. It would have been harder, though, to get any work done and probably stay afloat, I would say, just because one of the things you had to do with making the OpenMV product is actually make it useful in a way. And so that means providing an algorithm that has some kind of performance that runs on our embedded platform and that people can use and that moves the product. And if we tried OpenCV directly, we would have run into memory problems that prevented us from having any features of use that would have worked on it originally and felt requiring a lot of restructuring. OpenCV, for example, assumes that you have access to large floating point vector operations and also multiprocessing. And so, that's just kind of built into the library. So pretty much for every function, you'd have to go in there and change the code to get rid of the fact that it's going to parallelize everything. This is what makes it so powerful, but it also means that it's very, very well optimized not to target a embedded system, more or less.
Okay. So is that okay if I segue into one more question, Alessandro?
Yeah.
All right. Okay. So on that note then, I guess I kind of wanted to know, and I saw this again on your FAQ, but I want to kind of turn it into my own question here. Comparing OpenMV, the camera itself, custom board, custom, PCB, this is the OpenMV product, comparing it to, say, on the FAQ, it's a Raspberry Pi. Why would someone choose OpenMV versus a Raspberry Pi with a camera on it and or trying to build something out that way? But I want to change the question. Why would someone choose OpenMV to just say another SBC with a camera on it? And then maybe if you could give me some examples on how, like, OpenMV, you mentioned, right? Like, this OpenMV using your own custom algorithms and all this stuff makes for a very efficient product. So I'm kind of wondering if you have any like speed comparisons or any sort of comparisons that you can offer for someone to say, I want to choose OpenMV over an SBC and build out my own little SBC.
Oh, yeah. I mean, right now it's a little bit hard to do that comparison, but that's not future looking. So the point of OpenMV was for all the code to run on board the chip. So this might sound like, hey, what does that mean? Our whole goal of our library was it operates on the chip itself. Like if you look at all our old products, we didn't have SDRAM. We added it for the Plus model because a lot of people have been pushing us to take higher res images, but that wasn't the goal. The goal was kind of like, how can we develop this algorithm, this library, such that it runs without SDRAM? It runs on board the SRAM in a microcontroller. And what we're kind of looking like, I guess the best example would be. So this product doesn't exist yet, but we hope to release it soon, and I'll mention it.
Yeah, if you have an OpenMV camera on your desk, maybe you could show it up to the camera, because.
Yeah, I do. So here's OpenMV Cam. Really, it's just one chip. It's a one-chip solution. Really, there's some other passives around it.
Is that the H7?
Yeah, it's the H7.
Okay,
but
cool.
Here's an example of where we want to go. So this is a product that we're working on. We haven't released it yet, but this is called the OpenMV Cam Micro. And so this is the size of a quarter. We have a camera, a USB connector,
That's awesome.
Accelerometer on the back, crystals and everything. We haven't launched it yet because there's just so much to do and I'm only one person. And then a 4-pin connector for the Grove, for SparkFun's QWIC and Grove connector.
You saw it here first.
Yeah. And so when people are thinking about, hey, why would you refocus? When people are thinking about like, why would you use OpenMV over SBC? You're kind of missing the point, which is OpenMV isn't designed to be a computer vision camera in the same sense as everyone thinks about things right now. Folks think of computer vision as, I need to have some really smart person using these libraries. We're going to do some really crazy deep learning. We're going to get the most powerful processor ever, and it's going to handle one camera. So with OpenMV, the kind of concept was, how can we make the camera into a sensor that does one job in life? If you've ever seen Rick and Morty, and the Rick spawns this robot, and it's like the robot asks, "What is my purpose?" And the purpose is to pass butter. And that's what we're trying to go for. In that, with this micro camera, we've gotten the compute to an unheardedly small, a really small size. You can't do this with other chips because you need to add in SDRAM, flash. You got to have Linux running on board. All these various things. Versus my goal is, how can we make a camera that has one job in life, which might be it detects people and it makes the IO pin go high when people are in the image. That's it. That's its purpose in life. You plug it in, it turns on. If it sees a person, IO pin goes high. If there's no person, IO pin goes low. That's the kind of stuff I want to enable with OpenMV. Really just embedded cheap vision that turns the camera sensor into takes camera data, processes that data, and outputs very simple results that other systems can consume. and then drive the price of these systems low, where you can think about, oh, okay, I want to buy a face detection sensor that exists now. It outputs a serial string where like faces are in the image. That's its whole job in life. It doesn't do anything else. And the reason this is interesting is because then you don't have to think about, like right now, if you want to have a camera sensor do something high level in a product, even if that's like a simple thing, like I just want to do QR code detection, you have to bring in so much extra infrastructure just to handle that one simple task.
What about like connectivity? So like, I mean, around my house, I have these Nest cameras, right? So like I can see my front door, my front window, my garage, all that stuff. Like, I mean, I'm looking at the specs. Maybe I'm just missing. I don't see any connectivity. Have you ever thought about bringing in like connectivity and making this, again, a single purpose camera for say surveillance that connects to some edge device, right? And then streams it all to the cloud, and you could do a microservice there too, maybe.
Yeah. So that's one thing we've been seeing people do. I mean, so fundamentally, like I don't have infinite cash. I can't just like spin up 10,000 boards. And given that, I don't have the same price structure as Raspberry Pi. That's just the reality. I cannot, charge nothing for a board and kind of keep the company afloat. People will say, oh, I should just do that. I should charge the raw manufacturing prices, but then you just go out of business and people don't care. So, given I have to, like, we've hired a performance optimizer to make things go faster here. So there is like a function you have to run with, trying to keep board sales to keep the company going. One thing that my goal here wasn't to make a Linux replacement. Like, let me say that just to be clear, like everyone kind of wants to push me to do that, which is, add all these features to the board, have Wi-Fi, have Bluetooth. It does this, it does that. Like the goal was really just to make a camera sensor that outputs some basic data. And so, yes, we will probably build a system that has Linux on board. And also we will also have more connectivity for our default camera. But of course that costs money to add a Wi-Fi module to it. So then the price has to be raised. With our current camera, we kind of tried to add as much stuff as we could without pricing the thing too high in the manufacturing levels we're at. There is for our next gen system, which will probably be out when new silicon comes into play. We're going to try to add Wi-Fi and Bluetooth support just because people have really loved those features, and I think it would make a big deal. But kind of my more pure vision is something like the Micro, where we really just make the size of the whole system as small as possible and focus on the value add that you can have when you have a small computer vision system versus trying to focus on trying to replicate a Linux processor. Like we think that a Linux gateway that's combining camera feeds from multiple cameras is totally fine. That's totally cool to work with. Like a good example would be, let's say you want to make a robotic system that needs 10 cameras at once. So with the OpenMV cam, you could easily have each of our OpenMV cams running a feature detector to do one particular thing, and those all can be attached back to a Linux board over UARTs or over I2C or SPI or whatever. And that Linux computer then can run whatever necessary code to attach to the internet. And I think that'd be a much better model than trying to force OpenMV to be the do-everything device.
But I'm going to jump in here because I think what you raise is a really interesting point, right? It's the point of we have, like, the cost of silicon is really cheap, and we could do a lot with it right now. I mean, you just showed that camera, and you showed, you haven't showed it yet, but I mean, I know what your cameras could do. The Cortex-M processors, super low power. You didn't touch the fact that it's low power, right? So you could have this stuff run on a little battery for potentially months, right? I mean, depending on what you build. I don't know the latest, if you get any stats.
The Micro that I was showing again, like we were going to launch this year, but the coronavirus is kind of like that really was tough to handle as manufacturing our own parts. Like honestly, we got locked out of. We have two warehouses, one in Shenzhen and one in Hong Kong, and we lost access to our Hong Kong warehouse. So like half our products we can't touch. And so we've actually been running the company off of minimal amounts of products we had at our Shenzhen warehouse and just directing manufacturing lines there. So it's been a challenge to stay afloat during these times. But anyway, the Micro, the whole point of this one, it is low power. Like, one thing to keep in mind is our cameras draw 100 milliamperes at 3.3 volts. So, if you connect this to an Arduino, that's totally acceptable, and it won't like blow out your regulator. And again, the whole idea is that the camera does one job in life. It just like, let's say I want to detect QR codes. You can set it up so that it detects QR codes, and when a QR code is seen, it'll generate like a JSON list of all the QR codes in the image and send that over the serial port. Or it'll actually just output the string of the QR code, payload itself, and that can be attached to whatever.
And this is awesome, right? This is the idea of having a lot of sensors that are really low power, that could last for months, that are actually really low cost as well, right? So you could literally have like them everywhere. I mean, there are people that are kind of pushing the boundaries of what, coming up with ideas of what could be possible.
I want to find.
We're lucky. Sorry, no, I was just going to say, we're lucky because actually we've got with us someone else that we'll introduce before your demo, Prabhana. That is actually someone that wrote a book called TinyML. So let's bring him in. Dan, hey.
Hello, everybody.
Hello, Dan.
How are you all doing?
Welcome. Good.
Howdy.
It's really exciting to have you on. I think this is the perfect point to talk about. Well, just give a kind of pitch on TinyML, because I think Prabhana just explained why, from a technological point of view, it actually makes sense, right? To have like something as low power as a microcontroller running images, right? I think Daniel, you worked on kind of the back end of this on like TensorFlow, like micro, and it'd be interesting to hear your definition of TinyML and why you think is important.
Yeah, absolutely. So I mean, I think it's been like since machine learning started being a thing in the last decade or so, it's been something we've associated with deep learning. I mean, it's been something we associated with big, powerful servers running off in the cloud somewhere, doing crazy stuff with giant models. And that's where a lot of the development and a lot of the interest has been. But it turns out using the same algorithms and the same tools, you can run models on really, really tiny, low-power devices. And to me, that's much more exciting, because if you can run model on a device, so first of all, let's think about like what is a machine learning model. It's essentially machine learning is a way of teaching a program something. And when you're teaching, you're imparting knowledge. So a machine learning model is effectively a small piece of human knowledge encapsulated in a program, which is able to take inputs and understand what they are and give you an answer back that says, hey, I think this is probably this kind of thing. So it's one thing to be able to take human knowledge and deploy it in a cloud server somewhere far away that requires loads of power and infrastructure to support. But it's another thing entirely if you can push down pieces of human knowledge and expertise into tiny programs that run on tiny devices that can fit into just about anything you can imagine, and at the cost of like cents. So it's unbelievably exciting, and we're really just starting to see the beginning of the way this is going to transform the world. I think like the real amazing thing here is that instead of just having sensors out there in the world that are collecting loads of data and pumping it back, sort of privacy be damned, into cloud servers to be analyzed in some mysterious process later on, we just have sensors.
Sorry, no, I just stopped and I like showing this.
I want to say one thing. Let me see if it's going to refocus this camera. It's
just try to plug it in there.
Oh yeah. I want to comment on one thing. So with the micro,
sorry, that I didn't want to interrupt. I just
micro, it's the size of a quarter. Okay, draws 100 milliamperes in running. Can connect to a Raspberry Pi and Arduino via I2C or UART, and has USB on board. This is the camera. The camera, by the way, is 2 millimeters by 2 millimeters in size. You see that little cube there?
Yeah.
It's like the best picture quality ever, but it's literally.
Can it pick up? Is it capable? Is it capable of picking up like a QR code?
Yeah, totally.
See, this is like I would already think of a use case, with my whole cryptocurrency blockchain mentality. Like you could make an awesome hard wallet that actually is capable of scanning and scanning QR codes and sending funds. But I guess you'd have to have some sort of connectivity too. But yeah, that's pretty cool.
It's something. I mean, the whole idea is make this as tiny and as cheap as possible. So this whole thing, by the way, we have an IMU right behind the camera, so you can do like inertial measurement of the image. But no, this whole thing though, this is like you know, the bomb on this whole, like this thing would be selling normally if we do a production run of 1,000 of them, like we can sell it at $40, which is pretty good price. But you know, if we were able to crank production up to like 10,000 or 100,000 units, you could get this down to $20.
Wow.
And that's the kind of like, that's what we're trying to target, where we're hitting the whole package for the cost of a Raspberry Pi camera, not just, you know, the camera plus the compute being a separate thing.
Yeah, and the battery life, right? I mean, like that's a really interesting thing is compared to a Raspberry Pi. I mean, you can't run a Raspberry Pi off batteries for very long, right? I mean, well, depending on what batteries you have, but I mean, you know.
Oh, yeah. I mean, this is, again, it's like a sensor, so you can turn it off like in the middle of operation, turn it back on. You don't really have to be careful about its, you know, if you want to like power cycle it hard, you can just do that. So you can have another microcontroller. It's a very low power gateway, like a LoRa microcontroller or whatever, just anything that acts as a gateway that can be directly connected to this. This offers the vision, and you have some other part that does the master control and data upload if you want. Anyway, back to you, Daniel. Sorry.
Well, I'm really glad that you showed that, because this is just like, think about the difference between trying to run models in some data center somewhere with the support of an entire civilization's worth of infrastructure between you and where that's happening, and being able to do all of that on a device that costs $20 and fits between two fingers. Like, that is mind-blowing. That's what the future looks like, not this like horrible sort of situation where we've got like tendrils of connectivity reaching out into every little crevice of your home. Really, we want to just have objects understand what's going on in the world and help us out with stuff. And that's what we want the future to be, and that's why this stuff is so exciting.
So let's get into the demo then, while we have.
I was just going to say one more thing before we get into the demo. No, just to say, we haven't touched on privacy. I think Daniel was kind of getting to it here, but you know, it's interesting, right? You could do all this processing without having to send your data out. It means that your data is kept safe on the device, right? You could send out signals. I mean, Kwabena, you were saying you could have a pin going up or down depending on you've seen a person or not. So you could send that out. You don't have to send the whole picture of the person, perhaps.
Oh yeah, no, you don't. And what's nice about this is it lets people also, besides for privacy, just encapsulate problems in a simpler domain. Like, let's say I want to make all my light switches in the house detect people instead of like you having to press them. Now I can do that. I don't have to like figure out how, like, literally, if you had the project of I want to make all my light switches detect people, like, okay, just think about how ridiculous that gets so quickly if that's going to mean you have a SVC per light switch. So that's the kind of, you know, thing we're trying to go for is how can we deploy camera sensors in really stupid applications where it does it just does some simple task over and over again, even though it's like running a very complicated algorithm.
Awesome. Carl, you were going to ask something, or should we go into the demo?
Oh, no, let's go to the demo. I think I was just going to say what this does is it allows pervasive computing without invasive computing.
Exactly.
And that's kind of the whole dream of, like, I think everybody on this call is like, yes, we love technology, but there's always a downside.
Mm-hmm. Mm-hmm. And then back to your original question, Robert, about why don't we run OpenMV? It's because, given that this was the whole goal of my efforts, it's like, you know, you can't say we have access to SDRAM. Like, that wasn't the goal, to say that we have that. And so trying to figure out how you do everything in the lowest amount of footprint possible is the whole idea. I will say I've enjoyed reinventing the wheel a little bit with OpenMV. It's been fun to learn how to code all this stuff, but it wasn't my goal necessarily to do that. But it's just ended up being that way. Cool.
It's pretty epic, by the way. Kudos.
And now that we have a performance optimizer that we've been, you know, paying to help us make the code go faster, it's made a huge difference in the speed. You know, we've gotten some massive performance boost on a lot of our algorithms this year, like 4x to one of them. Their median filter went up by 10x in speed.
Wow.
which is just a testament to how little effort I put into writing that.
Right.
Okay.
The floor is yours.
All right, so you're gonna need to switch to my screen share.
Yeah, we can share that.
Okay, cool. So this is OpenMV IDE. So one thing to note is to make the OpenMV experience better, we have a IDE basically that kind of connects to the camera and lets you stream data out of it and kind of gives you the visual feedback of what the camera is seeing at the same time. And so it comes with examples. So it's built to be like the Arduino IDE. That's the whole purpose. And when I was talking about like doing person detection, literally when you plug the camera in, you get this little hello world script. You can see it's running about 30 FPS right now, and you can see me. And then you can go to examples and say, okay, I want to do like, person detection. And so I can just click this. This is a person detection example script. You can stop and start. And now it is detecting if I'm a person or no person. So you can see up there, no person, person. And so you can very easily script the camera then to control the IO pin, literally to just make the IO pin go high or low if a person or no person is in the field of view. Boom, you're done. That's one of your applications. Hey, now you can build light switches that detect people. You put a little delay timer on that so if it detects a person, keep the IO pin high for like, some amount of time. And if it doesn't detect a person, make the IO pin low. If it doesn't detect someone for a certain amount of time or whatever. And the micro that I just showed off can do the same script. Right now we're running on the H7 Plus, which is a little bit higher end system because people kept asking us to make the platform take higher resolution images and have SD RAM. Cool. And so I want to show off a new feature today that we added for training custom neural networks. So right now I was showing off with person detection a built-in network. So we have about so the person detector network is about a 260 kilobyte network built into our flash. And so anyone can use it with our product. It's already on board. But we have a new feature called the dataset editor, which allows you to create datasets. And so this is going to basically kind of let you capture images using the OpenMV cam to make a new dataset. This is called this dataset. Double click that, select it. And when the dataset editor opens, it'll basically open this thing called a dataset editor capture script. And what this will allow you to do now is capture images using the OpenMV cam of an object so that you can classify, make your own image classifiers. So let's say we have the micro here, and we want to make a class called micro. So we can click this and just say micro. Cool. And now that's going to make the micro class. And then we can just click here. And of course, this is out of focus. The pictures look jacked up, whatever. I'm not just trying to do a demo real quick. But you can take pictures of this object. And using the IDE, you can kind of capture all of your data set recognition images you need, basically. And so the IDE will make that easy. And then you can do another class like a SD card, for example.
It's storing these images on your computer, right?
Yeah. The whole purpose of this is to make it easy to train a TensorFlow network that does image classification. Like what I was showing off before was a person detector classifier. The camera's not, the focal length isn't set up to look at an object this small, so this is going to look terrible, but whatever. I'm just trying to show off the idea. But anyway, yeah, you can do this again and then capture pictures of SD card, right? And so this feature, what it's designed to do is give you a way to build a data set using the OpenMV cam of take images directly from the OpenMV cam and then build a data set using that. This is valuable because when you want to build a machine learning data set, you need to capture images from the sensor in the operational mode that it's running in. So like for us, for example, if you wanted to add lens correction or apply some type of rotation correction, like warp perspective or warp affine in OpenCV and have any median filtering or whatever, you can do all those operations in this script. And then that will output the same type of texture of data that you are going to be running in real life when the system is operating. And then you can collect images that all look that way. That way the machine vision algorithm, the CNN will have the highest performance. And then once you're done, you can just go to Dataset Editor, export dataset, and that will generate a zip file, which you can save. And that zip file then can be uploaded to Edge Impulse, which is what Daniel is here. And I'm going to show off, unless Daniel wants to show it.
Oh, you should go ahead. I'm not set up for a demo, but I can help talk through it for sure.
Okay, yeah. So let's do that then. So yeah, the whole idea is OpenMV IDE makes it easy to capture said image data sets. And this can be from thermal images that you take using the OpenMV Cam, using our Lepton adapter or whatever. We've had customers come to us and ask us really hard problems like, can you tell me the direction of wood grain, in a picture? Like literally, just imagine you have a piece of wood and there's the grain on that wood. And they ask like, they want to know whether or not the grain is upside down or right side up. And when you look at that, it's like, yeah, it's an impossible problem. I need a CNN to do it. And so the idea behind the dataset editor is now you can just deploy the OpenMV Cam in the right system, capture the images of the two classes you need to identify, and then it can do image classification for you to tell you the difference between those objects. All right, so let's switch to Edge Impulse now. So Edge Impulse is a new feature that has been worked on by, Edge Impulse is a new product and service that has just come out, and Daniel is part of the team there. It's made by Zach Shelby. And so Edge Impulse allows you to train a neural network for a microcontroller and do that online in the cloud. Normally, this is super intractable for most users because installing the tool chains to train neural networks is usually harder than doing the training for some ridiculous reason. Also it just doesn't work on everyone's platform. Trying to get that working on Mac, Windows, and Linux is typically very, very difficult. So Edge Impulse takes that all away. Now you have OpenMV IDE, which can run on Mac, Linux, Windows, and Raspberry Pi. So pretty much any platform. And once you have that data set that you can collect, you can upload that to Edge Impulse and have it do training for you. So this is an example Edge Impulse has posted called Plants versus Lamps. And so they have pictures of plants and lamps. And this is going to show them training a neural network to detect the difference between it. So let's go to data acquisition. So basically, Edge Impulse has this flow. Daniel, if you want to talk more about that real quick.
Yeah, cool. So essentially, you start out, you've got this empty project, and you gradually go through the process of adding data, adding a signal processing pipeline, training a model, testing the model, and then deploying it. So it takes you through this ML workflow. So the first thing that you do is think about capturing some data. So you've seen how we can do that with OpenMV's IDE. You can also bring your own data from any kind of source. You might have data sets you're using. You can even connect your mobile phone to Edge Impulse and collect data using the camera on your phone. And so once you've got your data set, it shows up in your data acquisition tab here, and we're able to automatically split that into a test and training data set for you. So here you can see a bunch of images that we've collected that are random stuff around our CTO, Jan's apartment. So some of them have a plant in, some of them have a lamp in, and other ones are stuff that is neither plant nor lamp. So what we're going to do is train a model, and this is all just collected with the OpenMV IDE. And what we're going to be able to do is train a model to recognize whether the camera is pointing at a plant or a lamp, and that will run on device.
Yep. So once you acquire data and upload it, and so OpenMV IDE is designed to make that data acquisition with the OpenMV Cam easy. And the goal again of that is just to make sure that you have images that look the same as what the camera actually sees. So you reduce the artifact rate of the neural network looking at different images than it's seeing with its own normal camera. And then you can go to impulse design. And so for our system, you basically specify, okay, I want a 96 by 96 input neural network. And then I want it to take images in from our, as the input, it's going to take an image from that data set. And then we're going to do transfer learning using MobileNet v2, actually, to basically take a pre-trained model that was trained on ImageNet and then do transfer learning to make that work with whatever image data set you provide so that it can classify it.
Yeah, so to just sort of give a bit more background on like what is transfer learning. So vision is kind of a general task. Like if you know if you can train a model that can see a load of different things, it understands what a load of different types of objects are, for example, the model will end up with a lot of general data that gives it an understanding broadly of vision. So there's a lot of theory behind it, but without going into too much, the different layers of the model essentially learn to distinguish different types of visual features. And then it learns how those different features are assembled or constructed into things that we would recognize as particular objects. So if you take a model that was trained to recognize 1,000 different types of thing, you can then take the same weights of that model and customize the model slightly so that it can really accurately recognize 2 new things that it hasn't seen before. So that's what we do in Edge Impulse. So we make that really easy for you.
Yeah, and this is the highest level of like, I've been wanting to do this for like a year now, but realizing given I have a day job and my time's limited and I can't do everything, we really needed to partner with Zach and Edge Impulse to do this. And we're so happy this feature is actually arriving because it really lets you now do what I just told you about, Robert, which is design a camera sensor that's dirt cheap, that has one job in life, which is detect X or Y, and you don't have to spin up a giant computer running TensorFlow and Linux and fight a whole SVC's deployment process just to have one basic feature of turning an IO pin high or low to classify between 2 different types of things.
I love it. I love it. I mean, I think this is kind of when what was it, 5 years ago or something, 6 years ago, when all these SBCs started to really take off and all these things started to happen in this embedded space. I remember speaking to folks from Qualcomm and how you start to think like there's going to be you cross a street and you're going to walk by 100 sensors just as you cross a street, right? And these sensors are going to be so focus fire use cases. This is just kind of like that perfect example. You definitely explained it well. I was thinking kind of like, oh, what could we add to this? What could we add to this? But I totally see the merit now in what you're saying. The camera is kind of like intended for this use case, this very isolated and focus fired use case. So I really like that.
Yeah, it's just trying to get away from literally everything happening and making it really complicated. Like we wanted to make simpler systems. Yeah,
that's awesome.
Once you get back to the training, like what I was showing off here is the system Edge Impulse will actually show off something called the Feature Explorer, and this basically shows you what the features of your images look like and kind of tells you whether or not you can separate them. So given these unknown versus plant versus lamp, you see how like the lamps are quite separate than the plants. And so this gives you an idea whether or not you can actually use a neural network to split your data. If you see like everything bunched together, it's pretty much impossible for a neural network then to do that also, just because the vectors look so similar. And then once you have that, you can do transfer learning. And so you might think, okay, that's going to take like years or hours to run. And actually, no. Edge Impulse, they've done a great job of making this stupid fast, and it'll be done, with training your neural network in a matter of minutes, actually. So you can upload your data set using OpenMV IDE, do the transfer learning, and actually have a working model in less than like 20 minutes.
Can I pause for a second here? So there is actually transfer. Is this a new feature, Dan? I haven't seen it.
So this is the first time the world has ever seen this.
This is amazing.
Pretty much we're deploying it right now. The press hasn't even gone out. So if
Are
you're
you
watching
serious?
if you're watching this right now, you're getting.
We can make a big splash here. We post
Daniel, you have to look into the camera and you have to point and you have to say,
let me make
here
you
first.
Yeah. you saw it here first. Copy.
There you go.
So yeah, it's super exciting. So this is landing right now. You're going to be able to use this in the next hour or so. Follow us at Edge Impulse on Twitter to get the blog post when it comes out. And basically, yeah, you're going to be able to just grab data. You can even use your phone if you want to get started before your OpenMV device shows up in the mail. You can collect some data, train a model, run through all of our flow, and then we'll show you deployment as well. It's so easy to get your model down onto the device.
Oh yeah, and just one thing, like we're using MobileNet. So for example, you can actually choose which models you want. Right now, this feature is super brand new, so it's not like we've optimized the heck out of it and like made it perfect. But right now they have 2 models, a 270 kilobyte one and a 687 kilobyte one. The goal is we're going to try to drive these models down to the closer to the 200 to sub 200 territory, while still having high accuracy, because that gets you to the area where you can have the model deployed on the H7 regular and the even the old M7 model. Additionally, in the future, we're probably going to have support in Edge Impulse, where it'll generate an OpenMV binary for you. So you might be able to literally have it output a firmware image that has a huge model using up most of the space. And we just strip out all of the OpenMV features that you don't need. And that way you can have a massive model then running on board. Right now, the model has to occupy the same space as the SRAM, so that limits it on the older OpenMV models. But we're going to optimize this flow to the point where you can have a large model running on board and maximally using the whole system.
And so we are going to be pushing these smaller models out over the next couple of weeks. So this isn't some distant future thing. We're going to have smaller base models for transfer learning coming very soon. And you can also play with stuff within Edge Impulse, like the resolution to reduce the RAM usage. So the input of the model you can make smaller. You can remove some of the latter layers of the model. If you know ML a little bit, you can really go deep, and it's super flexible, and you can customize everything. But if you don't have to think about it at all. That's sort of the thing we're aiming for. So yeah, awesome.
Expert mode.
So yeah, here you go. You can dive in and literally mess with anything you want. And you can even, if this isn't enough, you can download an IPython notebook to your own computer and just run the whole thing locally and debug.
Is that a Keras interface?
Yeah, it is. It is. So we try and use all these industry standard tools underneath, so that when we expose them to you, you can use all of the relevant skills you might already have.
This is just really awesome. I mean, I'll say this is rad. Like Robert made me say.
I accidentally posted on his.
Oh no, this is a picture that I've been hinting at and I've been talking about, and I'm so happy that it's finally here. I mean, awesome. Once we really get the steam rolling on this is going to unlock a new, universe of what you can really do with low power computer vision.
This is really cool. We've got a question. We've got a question for you guys.
Yeah.
So Andrew is asking in the chat, what's the recommended data set size for one of these neural networks?
Yeah, 20 to 30 images per class is all you need. Transfer learning is powerful.
Oh, sorry, I didn't mean to talk over you there. So yeah, basically, it depends really on your task. So if you have a really set environment, imagine you're like looking at objects going down a conveyor belt and the camera never moves, and you want to determine whether the object is a big triangle or a big cube, then you wouldn't need much data, because those things, they're quite different from each other and the surroundings don't change much. If you're doing something more complicated, like you have a camera fixed onto a vehicle that's driving around all kinds of different environments, and you want to recognize like objects in that context, you might need a bit more data. So it's something you'll always have to experiment with and play with. But the beauty of transfer learning is you can get away with a really small data set to begin with. So as a smoke test, I've been setting up on my desk this tape and this really crappy screwdrivers that I got from Amazon. And I took 20 pictures of each one, and I trained a model that's like pretty much like always gets it right when they're sat in a similar place on my messy desk. So you can really get started with very little data, but the more data you add, the more robust it's going to be.
Yeah, like if you're treating this as so just to say on that, like right now with this model, we have only 84 pictures, right? And we're getting a 94.1% accuracy. And remember, this is trained on actual images taken with the camera. So this is not like we trained it on images the camera has never produced before. We're using actual data that it generates. And it's able to kind of differentiate those very, very well. And then on board, we're running this at about 300 milliseconds per op time, and these are the sizes there. But back to the point about the images, the number of images you need. If you're serious about doing this to make it most robust as possible, there's a whole integration pipeline flow you have to get into where you actually tag images that fail that have low confidence scores, and then you have to constantly be re-uploading those back to the web and kind of getting those to training the model better. That's a future we want to bring. It's not here right now, and I don't think it's going to be here for a while, but getting the highest model accuracy is something that Edge Impulse is actually built for, though.
Cool. So one other question for Dan. When is the documentation for this coming out?
So there are already tutorials, videos, all kinds of stuff that's going to land in our docs. It might be there already. It would have been happening while I've been talking to you now. So, but yeah, there's going to be full documentation for everything, including video,
Awesome.
very, very soon.
Awesome. And last question for, I guess, both of you. So once you train a model, to download it, I mean, we were saying it's not really all fully integrated yet, so you don't get a binary for OpenMV, do you? So you get a model and you have to import it in the IDE. Is that the flow, or?
Yeah, no. So you just go to deployment, and so OpenMV, for example, we work using .tf-lite files. So we have TensorFlow Lite for microcontrollers fully implemented on board, and we literally include everything. So we have the entire suite of every single op that TensorFlow supports for microcontrollers on board the camera. And once you download this binary, Daniel, wait, do we need to push the latest firmware image for the OpenMV cam though, right? Because you MobileNet V2, correct?
Yeah, I think, yeah, it is using MobileNet V2, but this should work on whatever firmware it is that you last sent me.
Oh, okay.
I love the fact that this is like literally like, it's not just a demo. They're just creating this live. I mean, it's happening now.
Yeah. No, well, we're about to push a firmware update that fixes some image quality issues on the H7 Plus that people have been bugging us about. And then also we updated TensorFlow to support more stuff. TensorFlow is always kind of moving forward, so every time we do a firmware update, we kind of close the gap on what they added, you know. But yeah, no, once you're ready to deploy, you just click this download button, select build. And what that'll do is that outputs a folder, and that folder will contain, I don't think it's showing what's going on here. Well, that'll output a folder that contains the labels the label file, the TF-Lite file, and a classification script. And so,
so if you click on that green button there, I think we've got like a guide on how to do it. Oh, sorry. So yeah, when you hit build.
Well, let me just share my screen.
Oh, yeah, cool.
Okay, so
yeah, there's a little tutorial.
You need to run this on your camera, right? Like that's
yeah. So it'll output this, which is just like a folder with the labels and a TF-Lite file. Oh, look at that, we get that, which is just like a binary file, and then it'll output a classification script, which is just where'd that go? I hate when you copy things to your desktop and then they move. Yeah, anyway, so the classification script just runs just loads the network and runs that. And so you can just plop down your OpenMV cam and then it'll work. That's basically it.
Awesome. Wow.
So I wanna possibly speak with you, Kwabena and Daniel.
I think he just dropped.
Something no.
Happened.
Oh no!
No.
There's this browser window.
Maybe it's just like
let him download some hacky file that crashes his computer.
Click that build button and it'll be fine.
The Bitcoin scam coming up.
Oh no! Yeah, that was crazy. They made out with like $7+ million or something on that scam. God. Yeah, it was crazy. I mean, it was so underutilized though. They could have done so many. They could have got on Elon Musk's Twitter, talked trash about Tesla, and then shorted the stock and like made so much more.
Posted a link to the Innovation Coffee live cast.
Yeah, they could have done that. Yeah.
Click the stop share screen button, and that was actually the leave studio button.
I was gonna say real quick. I participate with University California, San Diego is my alma mater. I sit on the alumni committee for electrical engineering. I think it would just be so awesome to, get like 30 or 40 of these OpenMV cameras, get some access to the Edge Impulse stuff that you guys are doing right now, and like throw out a little hackathon and just see what students can come up with. Because I mean, with the IDE implementation, with everything that you guys have to offer here, I feel like it would just be such an awesome project to see, you know, like for students just come up with all sorts of crazy cool stuff. And like these use cases would just be awesome. So, I mean, maybe we could talk about this offline after the show. I think that would be fun.
I mean, super exciting. From our side, all of our tools are just completely free. So you can just start using them. Doesn't matter if you're a student or a billionaire, it's just completely free.
Nice.
So easy to get started. And then Kwabena.
Oh yeah, we're going to try to do for ARM DevCon, I think, whenever that's coming up, we're going to try to do a workshop with showing off all this. Hopefully by that point we'll be like mature and, you know, all the, like the obvious like huge issues will be worked out, because we're launching now and the workshop's in a couple months, I think. Alessandro, can you comment more on that? Like, when's ARM DevCon?
Yeah, I'm actually gonna let me just share. Let me just find it. Well, guys, talk for a second, and I'll be talking about something.
So it's actually ARM Dev Summit. So ARM Dev Summit, and it's in October. I believe October 6th through the 8th.
The 8th, yeah, exactly.
Yeah.
I'm just gonna share the link as well.
Yeah, and there will be like 100 sessions, mini workshops, birds of a feather, you know, like community gatherings. So it seems like it's going to be a lot of fun. Also, I think registration just opened. So
I was just going to say, registration just opened and it's free. I mean,
free.
It's a free conference. It's going to happen in October. Here's the link, and it's. I mean, we're gonna have you guys on, so it's going to be amazing, right? And it's actually. I mean, there's a lot of different things going on. You can see the schedule on the website. And there's going to be workshops. I mean, actually, to be fair, the workshops are the only thing you're going to pay for, because there is a limited set of number of people that can attend. So we've got that. You got to pay for the workshops, also because depending on the workshop, you might get some stuff delivered. So yeah, so the rest of the conference is all free. So make sure to check it out.
Yeah,
I'll be there.
Yeah, you know, just kind of hit us up about this stuff. OpenMV, we're just going to be pushing out some new firmware to kind of enable everything, and then Edge Impulse is going to kind of take it from there, and you know, get through their own integration issues of launching a new product and this new service. But you know, I did a look into how many OpenMV cams are in the wild, like how many we've sold over the last 5 years, and there's about 40,000 confirmed non-clone units out there. I've seen on Banggood, though, and other websites, that there's a ton of clones out on the market, so that might be closer to 80,000 OpenMV cams out in the wild. 40,000 I know of, though. And, you know, with all these cameras out and about, there'll be plenty of people signing up for Edge Impulse and trying this out, so there's going to be a community of folks giving this a shot. Join us.
It's going to be so cool to see what people build. I mean, it's like this always, where you build something and you have some idea of what people are going to do with it, but the main things that end up being amazing, you never would have thought of in a million years. So that's always the most exciting part of this.
Oh, and last but not least, to enable the OpenMV cam connecting to other microcontrollers, we've been working on an interface library for it. We pushed that out to the OpenMV cam itself, so the OpenMV cam itself can communicate to another OpenMV cam using the interface library, but then also a computer. And we're about to release an Arduino interface library that lets the OpenMV cam communicate over SPI, I2C, CAN, UART, and no, that's all four interfaces. So we're going to be pushing that out soon, hopefully by the end of the month. And then we're also going to be supporting Raspberry Pis and other SBCs, basically any Linux system that has you know, standard driver setup. So that'll also be UART, I2C, SPI, and CAN. And so the hope is to get that library out soon for Arduino, at least by the end of the month. And this will then finally unlock that vision I said, where you can have a micro camera that is like connected to an Arduino or whatever IoT interface device, like a particle photon, which already does all the IoT stuff. I don't want to reinvent that wheel. My goal is to focus on this little thing. And so you'll be able to like take the camera, take our interface library, have this guy act as a slave device where, you know, you tell him a command. Our library is something called a remote procedure call. So it allows you to say, I want the camera to take a picture and do a classification, and it'll return the result. and it kind of turns the camera then finally into that, computer vision sensor.
Cool. Well, we got people already waiting for the new feature going live on Edge Impulse. I shot JR. He's a big fan. I'm sure he also has an OpenMV cam. So I'm really excited. I mean, this was awesome. This is a really cool announcement. We've run 10 minutes past the hour, so I'm just aware that I want to kind of give everyone their time back. But I mean, this was a lot of fun. I mean, much more fun than I expected. I joined. I'll tell you a secret, everyone. I joined and I saw Dan, and I was like, oh, I didn't know what Dan was on, and then I realized that there was this big announcement coming. So it was awesome. Really cool.
I didn't know I was going to be here until about 2 minutes before, because I was hanging out with Kwabena talking about some launch stuff, and he invited me on. I'm literally wearing my pajama shorts right now, and I haven't brushed my teeth yet.
Edge Impulse pajamas.
Amazing.
Oh yeah, we don't have the Edge Impulse pajamas yet. That's a good swag idea.
I want the onesie with the footy pajamas.
Oh my god. Okay, well we do have a sheep onesie. There's some videos.
Oh yeah, I've seen them in all the videos.
The whole swag is gonna swag when events start opening back up. Swag is going to change. It's gonna be face masks and slippers.
Nap time.
Yeah, nap blankets.
Well, guys, I mean, this was amazing. This was a big surprise for me as well, and it was really awesome to have both Kwabena and Dan on the show. And I mean, these new features are just mind-blowing. I think I'm really excited to try it out. I've got my OpenMV. I've got access to Edge Impulse. I've been playing around with it. So I'm really excited to actually combine the two things together and see. I think, capturing data is actually one of the most painful things in the embedded world, right? It's super painful. And enabling that to happen fast, especially with a camera. I mean, without saying
it look so easy. They made it look so easy. Kwabena was just like click.
Yeah. And I mean,
that's what doesn't exist, right? Even if a Raspberry Pi, that's like a giant pain in the butt.
Yeah. Anything. I mean, I've tried in the past. I've tried to integrate a camera on a board. I'm not going to say any names, but it took me a week to get the firmware working. Like I'm talking about like from scratch, right? And it's just painful. I mean, being able to not do that and have like this work out of the box is just amazing. So thank you guys for making it happen. I mean, and I Kwabena.
Alessandro, can we give each of them maybe like just 30 seconds? Shameless plug. Putting. Whoa, chairs falling back. Okay, but just like 30 seconds, just so we can put up their website one last time. Say whatever you want. Like Kwabena, Daniel, say whatever you want about OpenMV. Say whatever you want about Edge Impulse. We'll put your website up, and then we'll close out the broadcast.
Yeah, I'll let Kwabena go first. So I'll put you up.
I think. Hey, thanks for checking out this web podcast, and I hope you enjoy the OpenMV Cam. It's a growing product, but we're trying to go to small places in the future. And I want to give a shout out to Zach Shelby and the guys at Edge Impulse. This video today and this new feature would not be possible without them. I remember having dinner with Zach a while back last year about this, and we kind of jazzed on the idea of making this possible. And so I'm really happy to see that it's finally hit and it's going to be released. And what you are going to be able to do with machine vision on the edge is totally going to change now with having the ability to do transfer learning and then run a neural network on a custom image data set on your OpenMV Cam on the edge.
Awesome. Well, that ties in well with Dan. You can do your shameless plug and.
Yeah. So, first of all, thanks very much to Kwabena and the OpenMV team, because it really takes, like, what's happening right now. I think you're going to see the world change over the next 10 years, in part because of embedded machine learning. And it's being driven by all these people with sort of big vision who have an idea and are pursuing it like crazy and building amazing things. And OpenMV is a huge example of that. And so Edge Impulse, our vision is that every engineer should have ML as a tool in their tool belt. And right now, there are so many gateways and hurdles and obstacles between you and training a model And our goal is to take those away and make things as easy as possible. And, we're just getting started. So we're really proud of what we've done. And you should check it out and start training your own stuff. But it's only going to get better from here. And if you want to deploy a model to basically
any lost Dan there.
Oh, have I disappeared?
Yeah, for a second.
I still see him.
Oh, I'm still here. But yeah, if you should try out Edge Impulse, build some cool stuff, and let us know what you're building, because it's you guys and girls who are going to be building the future. Like, we're just building the tools. So.
Oh yeah, one last thing. Was this recorded?
Yes.
You're live the whole time.
You're live.
Great, awesome. Yeah, I know we're live, but I mean, like, was it recorded?
Yeah. We'll post it tomorrow. So
okay.
Yeah, it'll be on YouTube. I'll send you. I could send you guys the recording as well.
Yeah, we'd love that. I'm gonna post this around everywhere. Awesome. And get my email list of everybody who doesn't really open the emails with it.
Awesome. Well, thank you so much. And I mean, Carl, Robert, do you guys want to say anything? Any last words?
No, I think that was it. That was amazing.
Yeah, it was amazing. I mean, as always, I just want to thank you also as well. Kwabena, Daniel, awesome. Thanks for being here, spending an hour and 30 minutes with us. So your time is valuable. So we really appreciate it. Thank you.
Yeah, I think getting the word out about this is really, the big thing. And I'm actually happy that we did the demo went smoothly, actually. So
it's fun. It's crazy, right? Like, you guys actually pulled off a demo that you were building like a minute ago, right? It's just like
it's just you guys are a combination of amazing engineering skill and even more amazing luck.
All right, it's always a big role. Well, guys, again, thank you so much for being here and for talking to us about what you've just done. So amazing! It was really, really, really fun to have you here. I'll say goodbye to everyone and see you next week.
Bye. Thank you. Have a nice day.
Bye-bye.